Hi everyone, welcome to ST Skills. This is a weekly system design session, and today we have a mock interview, and it's a volunteer-based nonprofit organization. So we alternate on the system design topics. This week we have a mock interview, and on alternate weeks we do a deep dive on one of the topics. If you're willing to volunteer, you can always join Discord and connect with Asim or myself or Vivek, like one of the organizers. And if you have any questions, hang on towards the end. After the session, we can have an informal chat. And today, like we have Namita volunteered for interviewee and Teja Menneni as an interviewer. So yeah, with this, like this mock interview is going to happen for like 45 minutes while we passively observe and get the feedback for both Namita and Menneni, and we can have a discussion on how we could have done the question better, like what Namita can improve and what Teja can improve. So with this, I'll hand over the forum to Teja Menneni as an interviewer. Please go ahead and start the question.
Thanks, Naga, for the introduction. Um, so today, so I want to ask about building a stock exchange platform like Nasdaq.
Okay. Stock exchange system like Nasdaq.
Yes.
Okay. Can you tell me more about the system? So basically, some people can like do we think that the stocks are already listed, and like do we want to figure out how to list a stock and how to delist a stock on this particular platform? Like what do we want to like list the stocks and delist the stocks, and then do we want people to trade the stocks?
Yeah. So the main components are people should be able to sell and buy stocks.
Okay. And so when the when person is coming to buy, there needs to be someone who is already selling it, and then only you can
Right.
buy, right?
Yes. Yes.
Okay. And if there is no one that is selling when you're trying to buy, then what is the experience?
So there could be multiple kind of orders in a stock exchange system, but we can just start with market orders. And if there is no buyer, you just time out after the market closes.
Got it. And if there is, so basically these orders are like limit orders that till the market closes, you can do it at any time. Is that how we want to do?
Yes.
Okay. Um, Okay, and even so for selling and buying both of them, we just want the same parameter that it is only available till the market closes, and
Yes.
we can't have like till in future date you can't have the order.
Yes. Yeah.
Okay, and so you are saying a buying or a selling price when you are selling a stock, right? Or when you are buying, what do you say, that do you want it at any price that someone is selling, or do you mention a buying price?
So normally in market orders, you just want to get the stock. So uh, yeah. So let's say we start with whatever you mentioned. So you mentioned this is the price at which I want to buy, and then if there is some seller available, you get that stock.
Got it, got it. So we will mention the buying price.
Yeah.
And similar way, we will also mention the selling price.
Yes.
Got it. So we are just assuming that there are few stocks that are already listed on the platform, and then we will only uh, allow that type of trading. We are not going into like listing or delisting a stock here, right? That is out of scope.
Yes. So just a correction. So I mentioned about market order, but we are building for limit order. So I just want to correct the terminology. So so let's say we're building for limit orders.
So limit order meaning like then you want to also do
So
it for
basically,
intraday? Mhm.
market order is you want to buy this stock irrespective of the available price, and limit order is you're putting a cap. So
Okay,
it's to you with what kind of system you want to build. Yeah.
got it.
So
But
you have clarity about the type of orders we are building. I can explain more if you want. You have more questions.
no, I think limit order. I just have one question on the limit order. What I've seen is with limit order, the expiry can be like in future day. Do we want like can I assume that it is only till the market closes, the
Yes,
expiry of
yes,
the
yes.
order?
Yeah,
Okay.
it's within the same day.
Okay. Uh, okay. I think so. In terms of like the non-functional requirements, I think when we are trying to buy and sell, we want this to be like highly consistent system, right? That when once you bought it, you really want to just say that you bought it and like it's a highly available, highly consistent system.
Yes.
Got it. Got it. Okay. I think I have like enough information to move forward. I would like to
Uh,
just put some. Mhm,
Yeah,
sorry.
sorry to interrupt you. So there's one more non-functional requirement in the, building stock exchange system is putting fairness in the system. So that also you should keep in the design.
Can you like explain me a little more briefly about fairness?
Uh, so so every client that is using the stock exchange, all
Mm-hmm.
of them should have equal opportunity. So in the sense. There shouldn't be some players getting higher advantage, and some, maybe some, like, everybody should get the equal amount of resources for usage of the system. So there should not be like, if there is a retail person, or if there is a high, in, institutions or multiple various types, right? Everybody should get the equal opportunity.
Got it. So basically, then whenever the limit order is coming, it needs to be served as part of like whenever it comes, you just have like one time based queue from where you are trying to execute the orders, and there is no like different people have different priority, and we don't want to put them into different queues to execute the orders. Is that
Yes, yeah,
how? Got
right.
it. Got it. Yeah, makes sense. All right. So I think I would like to start with some putting some APIs, and then I'm gonna put some high level design. So as part of APIs, I'm thinking like we will have mainly two APIs. One would be the buy API, where a person is telling, like a customer is coming and telling that I want like this stock label. This would be like a string. Apologies for that. So it will tell like what is the stock label that they want to buy, what is the quantity that they want to buy. I'm assuming here that you can buy multiple quantities, right?
Yes.
Got it. And yeah, I think that has like I have one more question. So if you want to buy like 50 stocks, but there is only 10 stocks that someone is selling, do we support partial orders, or do we just like cancel that order?
Yeah, we support partial orders. That's a good question. Yeah.
Yeah. Yeah, so you tell like what is the quantity of the stocks that you want to buy, and what is the price that you want to buy. So that is, and like who is the customer that is trying to buy this. Uh, and similar to the buy, we will also have like a sell API, where you are trying to sell something with quantity, what is the price, and who is the customer ID. And yeah, apologies for typos here, but those are the two major APIs that I feel we need to have. And for supporting these APIs, I think I'm also gonna put like just a little, not in depth, but just a little bit high level databases that I would need to support. Uh, Actually, I'll come back to this. So majorly, I feel, let me go back. Let me go to the high level design at this point. So this is like an actor. Because it's a highly available system, we will, I'm putting in load balancers right now here. Uh, this is a buyer, and this is like a system for buying. So you can call it like, I don't know, NASDAQ service. Um, and this service is going to basically talk to the databases to support these orders. And I'm gonna figure out like what are how this is going to work. So basically, when a buyer comes in, it calls this service saying that I want to buy. And when it wants to buy, the thing that I'm thinking right now is we would put all the orders in like a queue, because we want to make sure that we execute the orders like that are coming time based. So we put all the orders that we get in a queue, and then we basically execute the orders one by one. This is so all the executing of the orders are gonna be like asynchronous. And similarly, we will have uh, a similar system where the actor is a seller, and the seller is also talking to this NASDAQ system. Yeah, so this system, and there is one more one more queue where there is like a seller, or like selling order queue. And this is like buying order queue. So whenever you call this buy API or sell API, you put, if this is a buyer calls NASDAQ service, and your order is put into this queue for for future execution. And with the seller, your order is also we are putting it into a queue. Now we have like another system that is going to pick up from these queues one by one and going to start executing. One more thing that I'm thinking right now is we might also need different queues for different stock labels because of the ease of execution. So if you want to buy like Facebook stock, then we will have like with every stock label, we will have one queue where you put like buying orders and selling orders. So for Facebook, we will have like two queues, and for like Microsoft, we will have two queues and stuff like that. And those, that is how I'm thinking about like getting the orders right now, and executing the orders. So this is like a order executor service that's
So can you please repeat about why you want to choose different queues?
I'm thinking right now that if we have like different queues for different stock labels, then it will be easier to match up the orders. So I don't have to like go back into the queue to see what all are the orders that are pending right now, and do I have, if I pick only one queue for all the orders that I'm getting, then in my selling queue, I will also have like all the orders that people want to sell. And if if I'm trying to buy like a Facebook stock, and in the selling order queue, there is a Facebook order, but it's like somewhere at the end, then I might have to like process all the other orders, and then I will reach to that Facebook order. Rather than that, it's just like um easy way of matching that, do I have anything here, and if I have, then I keep on executing the order. So just like a ease of execution slash partitioning for the order processing. I'm picking different queues.
Okay, so you have two different queues, and in each queue you have partitioning based on the ticker or the stock label.
Yeah, that is, I mean, uh two different queues, and each queue have it's not really just two different queues. For each of there are types of queues. One is the buying queue, one is the selling queue, and for each buying queue there are like whatever is the stock tickers we have, we will have x number of queues. And for the selling queue also, we will
Okay,
have that y number of x number of queues.
got it. Okay,
So just for
got
the
it. Yeah.
diagramming purposes, I just like say that, okay, this is like a one ticker selling queue, and this is like a ticker buying queue. And the order executor service, what this does is it tries to pick, it basically polls this queue uh, every time, and then it tries to match that, do I have anything. It pulls this queue and the selling queue both, and it tries to match up that if there are any orders that I have that I can execute. For example, I want to buy like 50 stocks, and in the selling queue also, I keep polling this queue and figure out that, okay, I got 50 stocks or not. Then I basically execute the partial orders or not. And then what this service does is it puts that into a database saying, okay, I executed this order, and this is like an orders table. So once the order is executed, it goes to the orders table saying that, okay, I've already executed this order. And with order executor service, I'm for now assuming that we all also have like a payment gateway and whatnot. So that's something that I'm assuming, that whenever
I
a
think,
order.
yeah. So payment, I think we can leave it out,
Yeah,
assuming
yeah,
it's yeah. Okay,
yeah. So
you,
the
you
order
can fill it up.
executor.
Yeah. Okay.
Yeah, I mean, I'm just like putting a box, and then we'll not
Sure.
talk about it. So what order executor service does is it will also need, I think, access to the customer database, that what is the, like, how much money you have in your account, and etc., something like that. And once the order executor service figures out that, okay, you have enough sufficient balance to for me to execute the order, it and I have like a selling party that also wants to sell, then I am going to just deduct that much amount, and then uh, give you that particular number of stocks.
Alexa, stop.
So I'm just gonna give you those many stocks. So that is something that I'm thinking on the high level at this point.
Okay.
Do you have any questions, or do you want me to like go into details on to any components, or I can
Yeah.
go forward? Mm-hmm.
Yeah. I just want to understand, like, so this is a uh, very scalable system, right? So Nasdaq supports 60K transactions per second. So it has to be very low latency and highly consistent system. So I just want your perspective how the system is handling that much amount of traffic.
Yeah. So
Yeah, I mean, just keep that in the back of the mind. Just telling you because I think we didn't cover it in the beginning.
yeah, I was hoping to cover that like just a little bit later.
Sure, sure.
Uh,
Yeah, go
yeah.
ahead.
So because we want this to be highly consistent system, I think the database that we are going to pick is we will make sure that it is giving like a highly consistent behavior performance. So
Okay.
that is something that we are going to take care with the database choice. And for executing like those many transactions, we basically have like a service which is highly horizontally scalable based on like a load balancer and whatnot. So here I'm not really talked about like how people are seeing the price and whatnot, because that's like something out of scope. But once you have like buy and sell order API here, this service is something that we can make highly scalable. And in order to make sure that the orders are executed in like really less time, this is like the queuing system that we have made. And because that's the reason I picked like a ticker based queue rather than like one single queue to execute the orders. And that's how I'm thinking that it should not, it like scaling should not be a challenge. The only thing is it's the order execution will not be instantaneous. Is that because this is like a little bit asynchronous process, even though we can keep polling it for like every 10 seconds or every 1 second, 5 seconds, whatever we want to poll for. But this is this will not be like really instantaneous. It is going to be a little delayed transaction.
Okay.
So are we okay with that type of I mean that type of behavior of the system?
Yeah, sounds good.
Yeah. So okay. Now in order, so basically this is how we are. I'm thinking about this. I can deep dive into maybe going into like one of the flows of buy and sell, so we can execute that flow here. And I can also talk about like how the database is going to store everything, so that we can see if it is highly consistent or not.
Okay.
Yeah. So when a particular customer comes and says that I want to buy like X number of stocks, we are going to put this uh, sorry, let me just like write some major steps here. So customer comes and like calls buy API. When it calls buy API, they're like we have put that order in that ticker's queue. And that's it. I mean, once you put that into ticker's queue with, actually I will also need expiry here. Um, yeah, so we put that order into the ticker's queue, and we just say that okay, return true, because we already got your order. And at a later point in time, when similar to this in the seller API also, we put that order in the, so there is nothing much that is happening on the buy and the sell one, because it is just putting that order in the queue. And you just like say return true, unless there are like one more thing that we can do is when people are putting the order, at that time also we can see that if they have a sufficient balance or not, and then only we accept the orders. And at the end also, when our order is getting executed, we again check the balance. So balance checks shouldn't be at sell, but balance check should be at buy. So and with the order executor service, the thread that is running, so it's gonna pick like with like some 5-second delay or 1 second delay. It's going to poll the buying queue. Actually, it will say poll the selling queue. If there is someone who is trying to sell, then it will poll the buying queue as well, and figure out the matching orders.
Okay. So what is the order of the messages in each queue?
The order of the messages are whenever it comes, right? I mean,
Okay.
so it's like a FIFO queue.
FIFO. Okay.
Yeah, because we want fairness in the system. So this is like a FIFO queue, and with the FIFO queue, you'll keep start executing from the top of the queue and try to match those orders.
Okay. So we want best value for both seller and buyer, right? So how are you ensuring, you know, the order book is giving best price for both parties?
Oh yeah, that's I actually assumed that you were saying that buy it at a market price. But yeah, that's something I missed. So hmm. Yeah, so for example, if someone is telling me that I want to buy at like $5,
Mm-hmm.
and the yeah, so the buyer is selling I want to sell at $5, and then the seller is the first order in the queue that we have for seller is saying like $8, then this is not something that we need to match. I think we will have to yeah, we'll have to keep polling to see if there is any matching $5 order or not in
Mm-hmm.
the queue. Yeah, so we basically,
So basically we need the best of, I mean, the ordering should be, it should be the first one and at the same time the best price. So
yeah, first one at the same time, best price. Yeah, let me think. So in that case, we we would poll the queue to maybe like get some selling orders for some 50 orders, and in those 50 orders we see that if there is anyone who is trying to sell with $5, I'm not really 50 actually, we will have to figure out uh so with the limit sell, right? Whenever
mm-hmm.
you get that buying price that you're asking for, you execute that order, and if you don't get it, you keep that again in your queue, right?
Right.
Yeah, so you don't basically execute if there is no matching price that you're asking for.
Yes.
Yeah, so I think in that case, what I would do is I'll poll the buying queue for like 50 orders, and I will also poll the selling queue for 50 orders. I will see if there is any matching orders from buying queue and selling queue. Then we are going to execute those orders, and for others we are just going to put them back into the queue. But
Okay.
that's going to create not really, because if you are not really putting them back, you are just like I think that we can use something like Amazon SQS, where once you are trying to process a particular message from the queue, you that message becomes invisible, and then for the other threads to pick up. But when if at all that order doesn't get executed, then basically you don't delete that, and it just becomes available again into the queue. So we pick like the first 50 orders and then try to do that like again at another after 5 seconds. It is again going to repeat that process, that you pick all the 50, you put 50 from buying queue, 50 from selling queue, and then you try to just execute if there is like a matching price, and then you
Okay. Yeah.
execute those orders. That's how I think we will do it.
Sure. Okay.
Yeah, so yeah, basically yeah,
So,
so that
so basically, assume we can assume that there is some state we're maintaining, and then that is taking care of getting the best price, right? So we can assume that, and then we can continue from there.
uh I'm
I mean, I want you to focus more on the system design aspect. So because this is little more about the implementation details, right? I mean,
yeah
if you want to go a little deeper, it comes to the algorithms and those aspects. So
Yeah.
in terms
Yeah,
of
so
the,
basically, yeah, I think so just like keep polling 50-50, and then you try to just match it up, and then if you match it up, then you just delete it from the queue if you have executed from both the queues, and then you the order executor service is just going to tell you that okay, this order is already executed.
okay.
Yeah. So that's how and with the orders table, the schema would be something like this, where you would have like a customer ID, and how many are the orders that you have. So maybe the ticker ID, the price at which you bought the ticker, and the quantity that you bought. So that's how we will do it. And this will be like a highly consistent system, because once you put this order, then it's just going to be there for you to see that it got executed. And if we don't buy if we don't, like, at the end of the day, uh if we don't find any buying or a selling queue, like any orders that buy and sell, then at the end of the day, there needs to be like some process that is draining those queues and sending out messages which says that okay, I'm sorry, your order did not get executed, and that's it. I mean, so this would be like some draining process. Yeah. So this is also basically going to do the draining of both the queues at the end, and we'll have like some notification system that it is talking to, and we'll say that okay, it's just done. And this will also have some integration notification system that once it gets executed, we'll send a notification saying we executed your order. Yeah. Is there any other low level details that you want me to talk about, or otherwise we can try to talk about the estimation, capacity estimation, or how many orders that we are uh,
Yeah, I think
solving?
we are good. We can go for the next part.
Yeah. So with the capacity estimation, how many orders are we thinking that we are going to? I think you said something, but I forgot. What was it? How many orders are we supporting?
So we're supporting 60K orders per second.
Okay. 60K orders per second. And how many tickers do we have?
Let's say we have less than 1,000.
Got it. Okay. So with that, I think this service is going to get like a lot of 60K orders per second. This is including buy and sell both, right?
Yes.
Yeah. So with this, like, this service is going to get like 60K orders per second. So we will need like if we think that how I'm just trying to calculate that how many servers would we need to host this service, NASDAQ service. If I'm thinking that one host is trying to process maybe um I'm not sure, like 5K requests per second. If one host is trying to do that, then we will need 12 hosts. Mm, I'm not sure if the one host can, let's see that 100 requests per second one host can handle. So the number of hosts that we would need is like 16 to 10 to the power 3 divided by 100. So that's going to give me 600 hosts. So we will need like 600 hosts to host this particular system. And because we have like less than 1,000, I'm just assuming 1,000 tickers, we will have to have like in our system the queues that are like 2,000 queues, because for each ticker I have one queue, one buying queue and one selling queue. So I have like 2,000 queues that are running. And in order to process from these 2,000 queues the order executor service that we have, uh, we can also partition actually this service based on few of the queues. And if not, actually, let me think a minute here. With the order executor service, we would need it to talk to like that each of the thread that is running. We would have like dedicated queues that thread is going to talk to. So we can also have like partition those threads based on the tickers. So we can have like 1,000 of these the executor service threads, and threads meaning slash microservices if you want to, which are going to run the same kind of software, but they are just going to pull from different queues.
Okay.
So this executor service will have like 1,000 threads that are running, and they are just going to keep executing from this. And in if we think that like with one host we want to like have two threads that are running, then we will need like 500 hosts that are doing this. So
Okay.
that's like something on the order executor service. For the database, uh so for the database, because we have like so many things, so many orders that are getting executed at the same time, we can also we can actually partition this order table as well from the ticker, because that's how we have been partitioning everything. So this orders table can also be partitioned based on the ticker ID, and every time you have like an order that is getting executed and we need to make a note of it, we will go to that partition for that ticker and going to store this order. And for let me just quickly estimate that how much data will we need to store into this one. So if 60k orders per second are coming, and if we think that there is like 10-hour window for market, uh, then with each 60 into 60 to 10 raised to 3, that this is per minute, and then per hour, and this will be like number of orders per day that I have. So 36 into 6, uh 36 into 6 is 216 into 10 to the power 1 2 3 4 7. So that is the number of orders that I'm putting into this database like every day. And if you want to, because we don't want this to like go away, we will keep storing this data for like a significant amount of time. And in order to just calculate how much is the data, if we say that customer ID is like 4 bytes and the ticker ID is also 4 bytes, 4 plus 4 8, and quantity bought 4 bytes, uh, price is also 4 bytes, so it's like around 16 bytes of data per row. So we will need like these many rows, that this is like the amount of data. So it's like 216 into 10 to the power 7 into 16 So this is how much is the data that we are going to store each day in that table. Yeah. If we have to store it like for 5 years, then we just multiply it by that much amount of time.
Okay.
Yeah. Other than that, I guess, do you want like I think I covered like the major APIs, I covered the database design, I covered like how the order executor is going to execute the orders. Is there anything that you want me to cover that you think I missed? I guess because I covered, and we also went through the capacity estimation.
Yeah, so I want you to cover about the robustness of the system, because this is a very much it's a financial system, right? So how do you ensure even if some part of the system is down, still you're able to serve the system is still functioning?
Yeah, so with the Nasdaq service, if this service is down, then we are basically this is the basic bottleneck of our service, that if this is down, then we are not taking any orders at all. Uh, so this is a major bottleneck of our system, and we have to, and the reason that we can make this highly available is because this is not really doing a lot of things. This is doing is the only interaction it has is just adding things to the queue. If the
Mm-hmm.
queues are down, so that's where I think if we make it like a distributed service, then we should be able to support, like even if one of the hosts is down, then the other hosts are going to take care of this, and this service can be up because it is distributed. So that's because of the distributed nature of this service, I'm thinking that this will be like highly available all the time. Another problem that we might have in our system is if the queues, I mean, if the SQS is down entirely from Amazon, then that is another bottleneck that we have, which we are basically dependent on, but I think they are very highly available. That's why we can assume that we can just make sure that this will always be highly available, and we are going to take read from those queues, and we won't be I mean we won't be down, because the only thing that we will be down is if SQS is down, but SQS is also distributed and highly available. We should be fine. Another thing is the order executor service. If Yeah, that's a good point here. With order executor service, I talked about like having different threads that are reading from the queue. For each
Mm-hmm.
of that thread, also we would need like a rep. I mean, multiple hosts that are dealing with this reading and writing, because if one of the host is down, we don't want the processing to stop for one of that ticker. So we will also have like multiple hosts that are trying to execute, like trying to pull from those queues and then trying to execute the orders. If at all one of them goes down, then the other can take care of it. And yeah, with the database, we will again use like a partition database, so that is also something that we can uh, take care of.
Cool.
Yeah. With the having like multiple threads trying to read from the same queue, as we talked about here, to make sure that we have highly available threads, and if one of the hosts that is executing one of the ticker thread is down, then uh, the way to shield them both to read from the same queue is also we are going to rely on like the SQS's property on, if someone has already read that message, then for the other thread it's not available. So that's something that we can also rely upon.
Okay.
Those are the basic bottlenecks of our system.
Okay. Cool.
Yeah. I guess that's like pretty much about
Teja,
yeah.
do you have
Hello.
Teja, can you hear me?
Yeah, I can hear you. Hi, Nag.
Okay. Are you guys done, or like you need few minutes to wrap up?
Yeah, I think she's almost done. Yeah, I mean, you have anything else you want to cover, Namita?
No, I think this should be this is it.
Cool. Okay.
Okay. Thank you, Teja and Namita, for volunteering, and this was a good session. Now let's open it up for the audience to provide their feedback. Um, yeah, like now anyone is feel free to speak up and provide the feedback to Namita or Teja on their how they did. Shreyas, you want to speak?
I have a question like some sticker mismatch is coming. Okay, so in this case we cannot accumulate the buying and selling ticker. Means buyer requirement is 5. If selling is there 2 and 6 is there, so you can accumulate and sell it, right? This
Yeah,
some
yeah. So, so normally partial orders are allowed.
yeah.
So in the first come first order, whoever is eligible, that will be executed.
Yeah, but in case of it is not matching, we can accumulate the stock from the selling queue and sold it to the buyer, right?
I didn't get you about accumulated word actually.
Okay.
I think
It will be
Shreyas
still in the
was
queue, right? As long as the
yeah.
order is not executed, it is still in the queue. So
Mhm. So no, the logic is yes that what I'm saying. Suppose their buying request is coming for for one ticker,
mhm.
and but selling request is coming for suppose one on the front of the queue. This is for 5, and the back of second and the top of the queue is 6. Okay, so but first one is not matching with the buying request. So in this case, what will happen? Are you going to drop it, or you are accumulating that selling request and say, giving it to buyers?
So normally, like you maintain some data structure, and then you keep the lowest sorted by time at the top, and then you pop out and then execute that, and then you try to match with the
For
best
pop out, we
price.
can do multiple pop out, right? To match the
So
requirement
as
demand.
long as the price is matching, yes, you can.
Oh, okay. Oh, okay. You are also matching price. I got it.
Yeah.
Okay. Thank you.
Hey, Namita and Teja, it was a really good session. Uh, I had a couple of questions actually. So, um, I think you choose polling as a mechanism to get all the order details, both on buyer and seller side. Any technical justification on why did we choose that versus kind of push model? Um, uh, uh, So is it because there are other challenges there, right? So one is like if we discussed about threads, which is kind of polling a particular ticker state and matching the order. Is there a case where you pulled a message, but the thread uh, died because of some reason? So in that case, will the message is kind of lost? His order is kind of lost, and it cannot be recovered again, right? So there is no persistency anywhere for the
Right.
pending orders. So could that be a problem? And how are you addressing that?
No, so I'm again relying on the SQS's visibility timeout property here that I talked about, where if so the way that SQS works is if you read a message, then you have to explicitly give a signal of deleting a message once you are done processing it. So if the thread reads a message and it does not delete the message, like it doesn't finish it and it dies, then because of in the visibility timeout that you have, if you didn't delete that message, then it's again gonna reappear.
So
That's
you need to guarantee that a particular order is processed only once, uh, at most once, right?
yeah.
So so that's another challenge, right? So like if you don't acknowledge, and if the thread which pulled the message dies for some reason, so there are two problems there, right? Either the order is lost, or the other thread tries to again pull it and again try to reprocess it. So there could be a duplicate processing. So how would you manage this?
Yeah, I mean, yeah, that's a good point. What we can do to do like shield us from that actually I missed in my design is we will have like we can have some order ID here together, like when this service is putting that message into the queue, you also say that there is like an order ID, and if you are again trying to process that order, executor service trying to process that order again, it's going to see in this table that have I already processed this order ID. This is something that I don't have right now in my design, but that's a good point, and we can dedupe on that order ID to make sure that I'm not reprocessing that order. So if like the thread processes that order, it has it in the table, and before deleting it from the SQS queue, it dies, then uh basically next time it's going to show up again here, and next time when this executor service is going to pull this queue and trying to execute that same order, we will see this. We will also try to figure out if this is already present, and if the entry is already present, we will just fail that transaction there. But we can, with like, there are ways to shield us from reprocessing that same order.
Yeah, I think I had two questions, right? The first question was about the mode of pulling. I think you're polling basically, so that would actually, I was thinking, like, would it create any additional latencies because of that? Because it's not real time, right? So because people typically want their orders to be processed in real time or near real time. Since you're polling, that could actually bring in some kind of latencies there. Is there a possibility of making it near real time so that as soon as you trigger a request, it can be processed? Maybe instead of polling, maybe you could do a push model there.
So yeah, I mean, you
Like
could
for
do
example,
a
if
push
you
button.
replace this the simple messaging system, probably with kind of some kind of a storm topology or something, which can actually flush these messages orders to a bunch of worker nodes, which can actually keep track of the priority of orders based on their price and based on their any other time thing, and then the worker nodes can actually match based on the ticker. So it's just my thought process.
No, yeah, I mean, definitely we could also have done it using a push model, and but the push model will only trigger like that lambda or whatever is the process based on the buying queue. That if someone is trying to buy, then you just trigger a process, and then you try to pull the selling queue, and then you try to execute that order. The the main reason that I did not really go for the push model is because I mean, even we can set the pole frequencies to like very high pole frequencies as well, and we can achieve that same near real time. And with this whole polling mechanism, we don't I wanted to make sure that when you are trying to poll this whole selling queue and buying queue, we have enough matching orders that we can match against, and that's how I picked the poll versus push. But yeah, we could also have done it using push model.
Okay.
Yeah, I mean, I think one more thing. Sorry, Naga, actually.
Go ahead.
Yeah, so the requirement is about limit orders, right? So it need not be real time per se, but as long as you're getting the best price, I think it should be fine. And she's using
Yeah, that was
partition.
other. Yeah, got it. That was other thing because I really don't know the stock
Okay.
market. How does it work? So limit order is something new to me. So I
Okay.
just know buy and sell.
Okay.
I was really surprised when Namita was cruising along. So because the jargons I don't understand. So this is the limit order and all. Maybe other people may understand, but I would have definitely taken time asking questions to understand and spend some time there. So yeah, it was my case. So but yeah, so
Even for me also, I couldn't understand this initial the limiting order.
Okay.
So
I have
can
a
you
question.
explain that like briefly, Teja, so that like
Yeah, sure. I'll spend some more time on this. So actually, a limit order is you want to buy a stock at certain price only. So let's say you want to buy it, you want to buy Facebook at $100, but it's currently price is $120 or some $80. I mean, sorry. So if it is 120, you don't get it. If anything less than 100, you'll be able to purchase it. At the buyer side, seller side is you want to sell at $100, but currently people are purchasing for $80, $90. Anything less than 100, you won't be able to sell it. So as a seller, your perspective is you want to get the best price, and same for the buyer also. And that is about the limit order. Market order is you are interested in a particular stock, and at any cost you want to buy it, irrespective of the price. So that is more real-time use case, and their price doesn't matter, but getting the order is important.
So can anyone explain like how does limit order will work in this architecture? Just imagine that if I have, let's say, 100 user who wants to buy, let's say, just an example, ticker X, for example, and the ticker and that one is, let's say, $80, for example. How will that 100 use for 100 user this will work in this place? Like probably Namita can actually tell that as well. I'm just curious to know how does that fit here.
Sorry, can you, I mean, this is for the limit orders, right? This system already is built for limit orders. Are you saying that how will it work for the market orders?
No. I'm just asking for this limit order because I could not get the understanding of like how does the limit order work in this architecture.
Actually, he was looking for the workflow, how it is.
how the
Yeah,
actual
specifically from the
logic
workflow,
works.
and I think that's where I think
Yeah,
one of the
yeah.
comment that I will have eventually. But let's try to understand. I think this is the forum to discuss about that.
Yeah, so with the order executor service, right, with that workflow, what it is doing is it is trying to poll the buying queue and the selling queue for like top 50/100 100 items from the queue. If you are and you try to just execute from one by one in that buying order queue, if you think that you are getting anything out of the selling order queue that is lesser than what you are asking for, lesser or equal, then I'm just going to execute that order, meaning I'm just going to delete those messages from the queue and I'm going to add an entry into the order table saying that I have executed this order because I found a uh, matching entry. I mean, matching meaning lesser or equal entry in the selling queue. And that's why I found how to fulfill your buying order. And that's where I'm just adding this entry into the order table saying that, okay, I executed your order and deleting the message in the queue so that I don't pick this up again. Does that make sense?
Yeah.
But is your queue made of, I mean, like you were saying the queue is SQS, right?
Yeah.
So are you polling those 100 or 1,000 messages all, like to check which all have the closest like
Yeah.
limit order expectations?
Yeah, I'm basically polling like like you can do a batch poll where you can poll like multiple messages at the same time, and I'm polling
And
that.
if only one of them matches, you put all other messages back again.
Yes, yes.
So
Namita,
when you
one
put
more.
back, you're changing the order, right, Namita?
No, so I mean I'm not deleting them, right? So if
Oh,
I
you
don't
just
delete it,
process, but don't commit that if I processed
yeah,
it.
yeah.
Okay.
So
Got it.
yes, yes, yes.
Namita, one more enhancement I was thinking. So in the ticker, right, you can also put multiple queue based on the selling price, right? Based on the required buying price, you can choose the lowest price, then go to the higher price till the demand it meet. This is feasible also here.
So
Sorry, Shreyas, can you repeat that?
What I am saying is that we can also on that you are creating the queue, number of queue based on the ticker, right?
Yeah.
So on the ticker also we can put multiple queue based on the selling price. Okay.
So are you saying with the price range, I also
Yes,
create different
yes.
queues based on the price range?
Right. Lower to higher you can put it. So based on the buying price, right, we can pick up the lowest price, then go to the higher price. That will be violated some fairness policy, something like here.
Uh, so
Yeah,
how
sure.
many queues would you create, right? I mean, that is another problem. Like how many queues would you create based on the price range? And yes, that will also the whole fairness policy where whatever is the order that came first, you want to execute that order first is also something that we will not. Uh, I mean, yeah, if that is also another like a FIFO queue, we can do that. But the major challenge that I feel is I'm not sure how are we benefiting from the price range based partition in addition to the ticker based partition, because you will end up creating like a lot more queues. And
Why I'm saying it, there is a possibility of always mismatch. Okay, probability of mismatch is very much high here if you go by this process. So
hmm,
if you go by the other way, making multiple granular queue based on the pricing, okay.
hmm,
So there is a possibility of matching is very high. So in that case, we can process the request very fast.
hmm.
Instead of denial of the request will be very high in this process. If you create ticker based queue,
yeah,
that's
so
why I was thinking of.
1 minute, like like you were asking some question, like did you get the answer, like, or I have some
No,
follow.
I think I sort of get the answer, but I'm still again. I mean, this is not specific to the specific to architecture. I think I'm trying to learn this from. Imagine that this problem will be given to me as an interview, in the real interview. Then how would
Yeah.
I solve this? Right. That is what I'm thinking. I'm not actually sort of like
Okay.
taking
Okay.
sort of like as a negative remark here, but I'm just trying to think about it. How do I solve that? And what problem are I'm trying to solve and why? So that is what I'm just trying to get deeper into that. But I think I got the sense of it. But to me, I feel like one thing is,
Would this work, or like my question, like in general for Namita and everyone is, would this current architecture work scalably? Like, do you think like is this recommended?
Yeah, this is fine, I think.
I think one thing, what I think is that order executor is doing too much work. So I know that we just put the assumption here is that everything is so many threads here and things like that. But I think one person actually brought up that probably that, what happens if the thread actually fails, let's say when it's writing to the database, right? What happens to that? So I think order executor is actually doing too much work. So for the limit order specifically thing, the way limit order, what I've seen it works for the other platform is that you place the limit order and then it's not guaranteed that you have to respond that limit order, within like a few minutes. It's okay to be late, even if let's say the process have completed, but the notification could be a little late as well. And then I think limit order has a time as well, let's say daytime. So I think it would make sense to have this split that for a separate queue, which will just take care of doing this algorithm in the background, doing the limit order, and which basically essentially runs read the things from order table and then process that, which will sort of like reduce the load on the order executor service. Um, um, because order executor might actually doing a lot of database read and write at the same time. So that's just the bottleneck that I see there. So we could probably introduce that another service which will sort of like do this processing.
Yeah. Let's give to Sri Prasad. Sri Prasad, you have something to say. I think you may have some alternate thoughts. So
Yeah, I didn't understand how are we doing matching, and the can you, maybe I misunderstood. Hey, can you explain me once more, how do you match the buy and the sell order, assuming that I have got 100 orders for buying and 100 orders for selling for the same ticker?
Yeah, so this order executor is basically polling this buying queue, and we can set like how many requests would it poll from that queue. Let's say 100, right? So I'm polling the first 50 buying requests, and I'm polling the first 50 selling requests. If I don't find anything that is matching in those that if I find any matching price in the selling queue, then I'm executing the order. If I don't, then I just put all of them back into the queue, and I again like keep polling those 50
Yeah,
messages.
so that's where I got it out. Like, first of all $100 comes at the same time. So in terms of fairness, there could be a case where the first 50 that you polled got a match with the other 50 which was not even polled, which is still in the queue. And because everything came at the same time, now you have potentially missed a match because you choose 50 arbitrarily. One. Two, if you choose to poll like X amount from the buy and Y orders from the sell, then your number of comparisons is going to be X times Y. So in this case, it will be 50 times 50. And you're doing this for every ticker, for
Yeah.
every second. And that's a lot of comparison. And I don't think that's going to scale out.
Yeah.
That's where I'm wondering whether this polling business would make a scalability issue concerns for you. Your fairness itself is like a problem, right? Yeah, I want to sell at some price and you are arbitrarily choosing some polling number, and that I feel itself is like a legal issue.
I think in this design, if I understood what Namita was saying, every thread polls and holds the entries in memory, and the matching happens within that thread, I believe, right, Namita?
Yeah.
So in that sense, you are limited to only the orders that you're holding in that thread particularly, right? So in that sense, it is scalable, but it is limited in such a way that you are limited to only those orders which are sitting in that thread, right? You're not going beyond that. So there could be a possibility that there could be fresh orders coming in and sitting in the queue,
Yeah.
but they're still in the queue. It's not in the thread because it's kind of polling, right? So so you're limited by that. So this is what I understood. Maybe Namita can confirm this.
No, yeah. I think that's fair. If like for the first 50 orders that I keep polling and I don't have any matching, basically then my system here is just going to fail because it's just not going to execute everything. What
But
we
then,
might have to do is we have to poll the entire selling queue. When I poll the buying queue, we can poll the buying queue for like 50 orders, but for the selling queue I have to poll the entire queue, that how many selling orders do I have, and then I have to match it. I can't do like 50-50 from both. I will have to poll the whole queue. So every time I'm just trying to figure out how many orders for this particular ticker do I have, and then I'm trying to match it.
but
So
why are we polling is my question. Why don't we persist it somewhere and do the matching there? Like 2 heaps or something, or put it in a DB and then do a match. Why do we do this business of polling? That's where I'm getting confused.
Yeah,
yeah,
basically is pointing you towards like choosing alternate options, not instead of queues. So I would also, Bhumik wanted to speak. I'll give chance to him also so that like we can again come back to this. Bhumik?
Thanks, Naga. Yeah, actually, I had the exact same question as Sri Prasad on, the system going in the stalemate. If first 50 or first 100 orders are not matching at all, then you are not doing any matching, even for the new orders which are coming in at the end of the queue. The second question or the second concern I see, or rather, I want to ask the interviewer here on his perspective on, was it expected for the candidate here to go deep into the order executor service? That is first. And second is, you had given the flexibility of choosing the market order versus a limit order. Would a market order be a better choice for the system design here?
Yeah, so actually you are right. The market order could have been the easier option. I wanted to focus on the system design aspect because the limit order is more about the data structures and how you are, picking the best thing. So 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 I wanted to concentrate on system design aspect. So but she already have written the requirements, so I thought that might be the best case.
Got it. And one more thing about the transactions. So it was mentioned maybe once or twice, but I personally felt that that was a very crucial piece because the system is supposed to be highly consistent. So for example, if I'll use an example of Robinhood because I think that is more familiar to me. So if I'm logged in from two devices, let's say it is possible, and I just have $10,000 in my account and I'm trying to buy like from both the accounts I'm logged in. How are we making sure that I'm just getting $10,000 worth of stocks and not 20,000 because I'm trying to game the system. So that consistency aspect, according to me, was very important by using leveraging transactions and everything. I again want to get your opinion, Teja, on this one. That was that something you were looking for?
No, actually, I was expecting the client or stockbroker taking care of that. I was concentrating on the exchange side about the
Oh,
fairness aspect. Yeah.
I see. So Robinhood and everything here would become the client of this Nasdaq. I think that part
Yes.
was never brought up.
Yeah. Yeah. Yes. So yeah,
Makes sense.
actually,
Makes
yeah.
sense. Got it. Cool. Thank you. That's all I had.
Okay.
Yeah, just to
Yeah,
circle back on Sri Prasad's comment, yeah, I think like having a DB would have made things simpler for me. But yeah, when I heard the requirement of like having fairness and just executing like one by one, I thought I somehow just thought about a queue, and then I just thought that I can just pull it from a queue and then do things. uh yeah, I mean, I think I should have thought there a little more that a DB, rather than putting it into a queue, just putting it into a DB and having that poll from the DB would also have made sense. But yeah, yeah, I think I agree with you that a DB would have made sense there.
Okay.
the question here is like what we do for different quantity that still is like unclear. I mean, like let's say buyer wants to buy 100 the quantity and the seller wants to sell 500 quantity. The mismatch of quantities, how do we handle?
I think they already told partial orders are not possible. Either it's full or not. That was she clarified, I think, in the beginning.
Not
No,
So
partial.
actually, partial orders are allowed. I mean, I think that's what
yeah, partials are allowed actually
requirement.
Oh,
in
I
the
see.
requirement.
What about the case when nobody's buying, everybody's selling because company went bankrupt?
Yeah, you don't do and you don't execute, right? And you, at the end of the day, you just drain that whole queue and cancel the orders.
So let's say tomorrow someone comes in after you drain it, and then someone wants to buy it. How will someone that in that case the buying process work?
It will
In
not
that,
work if
in that
nobody's selling
No,
that
so
day.
actually, it's time bound. So all the transactions are happening within the market time. Let's say 10 hours on that day. So next day is again fresh.
I see. Okay, so I think we are not. Okay, I'm sorry. Okay, so in that case, we are building the limit order. Okay, I see. Yeah, that's right.
So I think to Sid's question, I mean, like you are doing some aggregation or like piling up some orders. Like if buyer is buying more, then the seller are selling few items. Like if there are 10 orders matching the 100 request of the buy, then you're doing that in the order executor service, right, Namita?
Yeah, yeah. The only thing is, I uh, I would rather. So this is a problem because of using a queue, because it's just gonna change the order, and I think a DB would have made more sense here, because I could just update the DB's like entry to say now I have like I was selling 500, but I already sold 100, so now I only have like 400 to be sold at this point. So with yeah, with a DB, that would have made more sense. With my queue design, this is, if I even update it and like updated message goes into the queue, it's just going to validate, like violate that fairness problem, because the new message is going to be coming into the like at the later. So yeah,
Okay,
I mean
I'll
that's a miss in the system design here.
okay, and I will let Singh speak because he is trying to speak for more time. After that, Sri Prasad and Bhumik, you can speak up.
Yeah,
Singh, yeah.
Thanks, Naga. I had a question to Teja. I think we are already approaching towards the correct design. So what if we have like multiple SQL shards, right? And we kind of place all of our, let's say, sell and buy orders, where we can order them by price in descending and then time in ascending order. So then if we, let's say for a given ticker, we have all the orders in this order, we can query, let's say, the sell table and then the buy table and see if there's a match. What do you think about that?
Okay, so I guess, I mean, actually, I'm not sure about. So I think by design it works, but I'm only worried about the scale because you know you have to support 60K transactions per second. So if SQL systems support that much scale, I think it works.
Okay, so with maybe we can have like an in-memory buffer for the processing server, right? The server that is processing for a ticker, it can have in-memory buffer both on the sell side as well as the buy side, and the buffer itself is like a priority queue, which is ordered based on the desired order, right? Like the descending order in price and then ascending on time. And then this buffer can basically be fixed size, and then whatever items come inside the database can be brought up into the in-memory buffer. And then whatever, let's say we have a size of 10, right, for the buffer. So if a stock, if an order is of, let's say, a very high price and that is not being executed, that will basically move out of the buffer and go back into the table, the relational table. Is that a fair assumption?
Yes. Yeah.
Okay, thanks.
I think there are challenges there, right? So the thing is, like, again, if you are having persistent and in-memory copy, how will you make sure that you are processing one order at max once, or how will you make sure that it's not the message is not lost?
So persistence
Because
for like, let's say if we place an order, right, we insert that into our table. Once it is processed, we remove it from our table, right?
because you have this heap, you mentioned about heap, right? So that is sitting on in memory, right? It's not on
Okay.
DB.
Uh-huh.
And if that node goes down, so all the messages that was there in that heap will also go down, right?
Yeah, that is an interesting problem to solve. Yeah. So if we are doing with like if we are using the in-memory buffers, then we need to definitely take care of this problem of
yeah, you can't fully rely on the in-memory heap structure here, because you don't get the persistency, because you will definitely spend some time draining all the messages from the heap, right? So, and you can even fail in between.
So okay, so
So
let's say if we
yeah.
have this heap, but when we fetch the message from the table into the heap, that is not that is a non-destructive operation. So the order is still in the SQL table, so it is persistent. But once we execute it, at that point we remove it from the database. What do you think about that?
Okay, I think we can hang on and discuss more towards the end. But like in the interest of time, like I would request everyone to give feedback to Namita and Teja, both of them, like on how they can improve in the next their mocks, like our system designs. And then like we can hang on and chat more towards the end after the session. So Sri Prasad, you want to go ahead?
The one small check I
Yeah,
wanted
yeah.
to, the in that order. Can you go a little bit up about the order executor service? Yeah, that one. The payment information and all these things you are doing at the time of matching. And I believe, like, if you are doing a buy, you should do all those payment things before you go into the queue and other things. Like, that's the first thing. If I want to buy, do you have money? If I don't have money, I'm not even letting you go ahead to do any kind of a match process. That itself will stop my, like, most of my orders, because right now you are doing a match and then you are checking whether he has money or not. That I feel is a it's okay, but it could be better by doing this check earlier, by blocking if you don't have money, then you can't. Like, if I have only $100, I'm not going to purchase 50,000 worth of transaction. That was a small thing which I want to point out.
So, Shri Prasad, I think I wrote that in my API here, that when you're trying to buy, I do a balance check and then only do this. This
Got
is another balance check, that once you put an order, at that time you had money, but when the order is actually getting executed, you don't have money. That's a
Got it.
possibility. And this was just like another check, just to make sure that when you put in the order, you had it, but now you don't have it because you bought something else. Like, just to shield the customer from buying more than what the balance is, there was one more check.
Got it. Yeah, that makes sense. Yeah, thank you
Yeah.
for clarifying.
Okay. Any feedback for Namita? If no one has, maybe Teja, you can go ahead with your feedback on how you think she did it.
Yeah, sure. Yeah, so first of all, I mean, she did a good job. Like, she was able to build a complete system, able to drive the conversation, and able to understand the main components of the system and covering all those aspects. So, so I think that is good. So yeah, she kept asking about she did the she understood about the functional, non-functional requirements, and she was able to draw the working high-level design. And she went deep into the how particular flows are working, and then she's able to estimate the storage and the other requirements. So those are the good parts that went well. Uh, but in terms of improvements, I mean, this is my perspective. I think different people might have different ways of doing it. I I would have started understanding the scale first and then design the system in terms of, let's say, how many stocks we have or how much transactions we are supporting. So that might give a better picture before I draw the system. So that might be one thing that can be considered. Uh, and apart from that, I was talking about the fairness. So it is so one thing good is she kept asking of each thing, like when I gave a requirement, this is actually little a domain driven kind of a new kind of system. Most people are not familiar, so understanding terminology is tricky. So she kept asking questions, but if I am in that situation, I would have asked more questions and make sure I understood the problem correctly. And I wanted to ask about market, but she kept, I mean, Namita written about limit order, so I kept continuing that, and that made the problem a little harder. So yeah, maybe, yeah, understand asking right questions might help, in designing the system that I have in my mind. Maybe that will help.
Okay.
And yeah, so that is one aspect. And a couple of things in the design is uh, so one thing that what I observed is maintaining multiple queues for buying and selling. I didn't really understand the advantage of keeping multiple queues. So maybe I can maintain in a single queue and then partition or multiple queues for the tickers, but specifically for buying and selling multiple, I didn't clearly understand. Maybe there is some particular reason, but I asked once, but still I didn't get it. So
Okay.
so yeah, that is one thing. And as others mentioned, I didn't really wanted to cover about the payment. I mean, it's good for the sake of complicity. We want to keep it, but the order executing is a mission critical service, and the way it is looking now, it is doing too many things at once. So, so yeah. So maybe we can introduce another queue, for the notifications or something, sort of that kind of stuff. But yeah, I'll keep it a very single responsibility and making sure I'm concentrating on the matching part, which is the core of the problem. So that is one thing that, yeah, can be considered. Uh, and yeah, so I think, yeah, I covered everything. So these are all I have noted.
Okay. Thanks, Teja. I think that was a good feedback. Namita, you have any questions or thoughts on that?
No, I think thank you, Teja, for the feedback. I guess rather than queue, if I would have used a DB, and uh, like maybe when you said market order, I somehow understood limit order, and that's why like started designing the limit order. Maybe yeah, I should maybe clarify a little bit more on to say that what is exactly a market order, because when you said market order, I thought it is a limit order, and I
Yeah, makes
started
it
writing about it.
happens. Yeah.
Yeah. So yeah, a little bit more clarification, that is this what you mean, would have made it a different system for me.
Yeah.
Yeah, okay.
Any feedback from others to both Namita, or even it can be for
What
Teja?
is that number 7 on your list, the requirement list? What's number 7 in that, please?
Partial orders.
Okay.
Can you just a little bit go down on the diagram, please? Thank you.
Okay. Shri Prasad, you have some feedback, Annie, or like anyone else, please feel free to provide.
I'll just talk a few lights. Like, you asked a lot of good questions. Your back of the envelope calculations were like really awesome. High availability is a requirement for such kind of stock applications, but also is consistency. That I think we should also look on. Again, you did a very good scalable design. Like, you put queues, you put DB, load balancer. So scalability, I think was good, but something that you could work on is correctness, that fairness of order. So that correctness part, because that's the core of this application. And yeah, that's the few lines that I had to say. But you did a good job, like talking in front of people. That's very difficult. At least for me, I know for sure it's very difficult. Thank you for volunteering.
Okay. Anyone else?
Thanks, Shri Prasad.
I have a comment here. So there were a couple of pieces which were not covered here. I think that was intentional. That's why I wanted to bounce this idea and check if that was the expectation. So the market hours. So NASDAQ may have different market hours, and if there is, other market which we are looking at. So the system we are building here, that is not taking into the consideration scaling scaling for different types of markets. And the new stock ticker. So there is 1,000 queues for all the 1,000 tickers. What if it grows and grows? Does that become scalable? And the third thing is the hot partition. That is, let's say there is a new IPO and that stock is very much in demand, or maybe for whatever news are out there, the stock is in demand. How are the hot partitions handled? So those are some of the things which are not covered. but I don't know whether they were supposed to be covered or not. So maybe Teja, if you can talk about them, like was that part of the expectation? Would those things been good to have covered here?
Yeah, definitely. The hard partitioning, the hard to, you know, yeah, that was a thing that I wanted to cover in the design. One stock is having higher number of transactions. How do you handle that load? Yeah, that is definitely a question, and the other questions as well. So I would have really, it would have been good if we have clarifying questions about whether we are building the system for a particular market or is particular to country, or, yeah, those questions might have been helpful. Yeah, but the main thing is about that handling the hard partitions. Yeah.
Got it.
So I,
Thanks.
I want to
And
clarify one thing here. There won't be any hot partitions like in this design, even though this whole queuing thing it doesn't work for partial orders. But if we don't consider partial orders, then because we are doing a polling and the polling is at one frequency, even though how much ever orders that you have, the system will be able to handle that. uh, I'm not like justifying the partial order system incorrectness here, but with this type of model where we are just trying to poll at our own frequency and we don't it's like asynchronous, I don't see hot partitioning becoming a problem. You are just like adding more orders. If at all people are trying or buying or selling more queues, you're just adding the more orders into the queue, and then the order executor is going to execute it at its own leisure by just add like yeah doing everything at a later point. Does that
yep,
answer
yep,
your
makes
question?
sense. Yep. Yeah, you're basically uh, changing the processing flow with the help of the queue. So yeah, that is fair. And one more thing was with regards to the customers of this system, right? So I know we talked about it, but I still wanted to bring it again, and maybe Teja, your point of view on how would that have made a difference here? That is, brokers being the customer of this system and not users like regular people like us who are, not the brokers. Would that bringing that into this discussion made any have made any difference, or were you some was that something you would be looking for?
So yeah, actually, when I was talking about fairness, I had that in my mind. So, so normally the clients for stock exchange will be stockbrokers, and there will be high frequency traders, and usually the first person who establishes the connection, he'll have advantage over the ones who get the connections later. So yeah, I mean, yeah, that would have made the system a little bit different, but yeah, that is also one important thing.
Thank you.
So normally what the traders or some people who want to do unfair practices, they can try to when you have multiple systems, like, so here in the cell thing, right, you're directly connecting, you're not going via load balancer, you're directly connecting to the Nasdaq service, right? So you can try to bring down the system, so you know exactly at what time the system is going to down, because you haven't found some way to directly access the system, and then you can do some computations based on that time. So yeah, so that is also important in the system.
So Teja, if I may ask you, can you like briefly explain what was the system that was in your mind for the market orders, just for like everyone's knowledge, that what would have made
So,
the
so
system
in
what you
terms of
wanted?
market orders, I think it is we don't need to worry about finding the best price of the user given. So you just go with whatever available sellers, and then you pick the best one. So in terms of the other aspects, system design perspective, it doesn't change. Only how you are building the data structure or the state in the order executor service, that is going to change. Either it's a market order or limit order. So, because in the limit order, you have to, maybe you are doing quadratic computations to find the best one. But in market order, it could be different. But the other system design aspects remain the same. That is about the market order. But about that fairness, the things will change a little bit, right? So I want one entry point to the entire system. So I don't expose multiple points. And I ensure that people don't abuse the system and take advantage of out of it.
Yeah.
This is what I had in my mind. Yeah. Did I answer your question? Answer your question, or you're
Uh,
asking about something else?
I just have like one. So basically, with the fairness, I think you were talking about having different Fidelity versus Robinhood versus all those clients to the Nasdaq service client, and you were you looking for maybe like throttling their traffic based on the number of orders, or like what when you mean fairness, what were you really looking for? I'm still not very clear.
Okay. So let's say market opened, right? And someone want to buy a stock, and there is some news that let's say someone want to buy a stock, and market just opened. Whoever gets access to the system first, whoever places the first order, whoever can enter into the system first, he has the more advantage, right? So what people can do is, when the market closes, still you keep connecting to the database till the market is open. So over the night, you're still trying to connect to the database. You keep polling that load balancer, and then as soon as the market opened, you entered the system as a first person. So you get advantage, right? So you have to handle those kind of unfair practices. There's only if there is only one entry, and then somehow you're able to figure out that some people are doing these things, you can, maybe you can throttle them, or you can limit those kind of things. I mean, am I able to express myself, or just want to understand?
No, yeah, I mean, it makes sense. The only thing is, even if you start from the entire night trying to establish a connection with the load balancer, or you try like at that moment, I'm not very, maybe I have to read up a
I'm
little
just
bit then.
taking one example. Yeah, there could be multiple ways, because there are high frequency traders, right? So in Robinhood, actual humans are doing the trades, but in high frequency trading systems at millisecond are able to, want to buy or sell. So there are different kinds of patterns that you see from the stockbrokers versus high frequency trading systems. So there could be multiple ways people want to abuse. So I just told one of the example that I read about.
Got it, got it.
Yeah.
Okay. So any other feedback? Okay, I think we're yeah, my quick feedback, I mean, like, I agree with most of what people said. And Namita, I think you did pretty good job. Your command, or like your communication is pretty good, and your flow, like overall flow, everything is good. So just in addition to things like they just said, like, yeah, at the beginning, like asking the right questions actually will help catch. And same thing, on a similar note, like I'll have some feedback for you also, Teja. But like Namita, I think your flow and your diagramming skills and your capacity estimation and the timing, like you did like pretty fast, I would say. So I think from your part, like you did best according to your knowledge and stuff, and you're trying to ask constantly to Teja that like is there something you want to cover? If not, like you are proceeding on your own, like let's do the capacity estimation, and you yourself figured out like you need some cleanup job for this, like yeah, like adding blocks, diagrams. I think everything was overall pretty good. And yeah, just make sure that like when you're presenting an options, like some solutioning, as people pointed out, like think whether this is the right, or like list down multiple options and choose one. I would go if you have in doubt. That's the only thing. And to Teja, like if as an interviewer, like if you wanted her to go in certain direction, you can always either ask her like, I didn't get that, like can you elaborate, or give her a situation where you think this might not work. Like for example, the queuing system, if that wasn't clear to you, like maybe you could have asked like questions in a different way as an interviewer, so that like she realizes her why the queues may not be a good choice, or something else, like what according to what you actually wanted to focus. And
Sure.
similarly on the requirements also, if candidate is not asking right questions, but you want to judge on how she designs a particular thing, you yourself can try to give more, but like just note in the feedback that like you felt like she didn't ask more questions or something like. I think those are the only small things, but otherwise, like this was a pretty good session, and we had a good follow-up discussion also. Asim, are you there?
Yeah, even I felt the same. I really liked today's session. A new interesting problem we haven't seen earlier, or not even a closest of that. So this is a really interesting problem where you have a really big system, different moving parts, which one you want to focus, and that would be a good call out at which place you want to go. You won't want to be uh, uh, going in that direction, which is the most complicated thing. If the interviewer don't want to take it to that way, and then it's fine. Take this south 277th Street exit. So I like the way Namita presented, and even how Dija ran the show. So there's always options of improvement, but this was really fantastic session. So I really liked it, and most of people already covered the feedback, so I won't go much into that. But take the south 277th Street exit.
Okay, thank you. I think you're striving. So, anyone else, like before we stop the recording and start the informal? Okay, again, thank you, Namita and Teja, for volunteering. This was a good session.